have learned about the different functions of these macro and micronutrients in plants. Now, the next question is, what if we don't give the plants these essential nutrients? What if they become limited? All essential nutrients have a concentration which is considered to be normal in different plants. At this concentration, they help the plant to survive. When this concentration goes beyond a certain level, it becomes deficient. And when the essential elements become limited, it would lead to retarded plant growth. The level below which the levels become deficient is said to be the critical concentration. Because the normal levels for different elements are different, the critical concentration of these elements can also vary from one element to another. Essential elements have either a structural role or a functional role in plants. Now, when any of these elements are absent, the plant starts showing certain morphological changes. These changes are indicative of elemental deficiencies and could be called as deficiency symptoms. These symptoms can vary among elements, and when you supply the plant with the essential element, the symptoms disappear. But when the plant is deprived of the essential element for a long period of time, it leads to the death of the plant. Now, where do we see these deficiency symptoms? This depends upon the mobility of the element. Now, what is mobility? It is the ease with which we are able to move an element from an older tissue in a plant to its younger tissue. So, we see that as a plant grows, the older tissues die off and new tissues or new leaves start coming up. Now, plants do not waste their elements. So, what they do is, as a leaf is getting old or as a tissue is getting old, it removes all the nutrients that it can from that part and utilizes it for the upcoming new tissues in plants. But this doesn't happen equally for all elements because the mobility differs. When an element is more mobile, they are easily able to move from older to younger developing tissues. And in such cases, the deficiency symptoms first appear in the older tissues. But if the element is immobile, they are not able to move from older to younger tissues, and so the deficiency symptoms appear in the younger tissues first. The deficiency symptoms of mobile elements like nitrogen, potassium, and magnesium first appear in the senescent or old leaves. Although these are part of biomolecules, they are broken down and mobilized to the younger tissues. Immobile elements like sulfur and calcium are the structural components of the cell, and therefore they are not easily released by older tissues, and so the symptoms start appearing first in the younger tissues. This particular aspect of mineral nutrition is very important to understand in agriculture as well as in horticulture. Now, what are the different deficiency symptoms we might see in plants? One of them is chlorosis. It is the loss of chlorophyll and yellowing of the leaves. This could be caused by the deficiency of nitrogen, potassium, magnesium, sulfur, iron, zinc, manganese, and molybdenum. The other symptom is necrosis, which is death of a tissue. This could be caused due to the deficiency of elements like calcium, magnesium, copper, and potassium. Another symptom could be inhibition of cell division due to deficiency of nitrogen, potassium, sulfur, and molybdenum. Flowering can be delayed when there is deficiency of nitrogen, sulfur, and molybdenum. New leaves and buds can fall prematurely if phosphorus is deficient. And when there is a nitrogen deficiency, the plants can show stunted growth. You will notice that the same symptoms can be caused by the deficiency of different elements. At the same time, deficiency of an element can cause multiple symptoms. So, to identify the deficient element, we have to study all the symptoms that develop in various parts of the plant and then compare them with a standard table. Different plants respond differently to the deficiency of the same element as well. Mottled leaf of citrus is caused due to zinc deficiency. This condition is characterized by yellowish white patches on the leaves, stunted growth of the new leaves, as well as the shortening of the twigs. Dieback of citrus is caused by either copper or zinc deficiency. It makes the new leaves to wilt or fall off. The twigs also die, and the leaves can drop prematurely as well. Heart rot of beetroot is due to boron deficiency. It leads to the browning and decay of the root part. So, because beets are the root of the plant, you would see these rotting tissues within them. And because the roots are rotten, it leads to the death of the growing plant. Next is the whiptail of cauliflower, which is due to molybdenum deficiency. The shape of the leaves change. They become distorted strap or whip-like. There is overall stunted growth and they are unable to form curd. Curd is the bud-like structure that you see in cauliflower. This is usually seen in acidic soil where molybdenum availability is reduced. Bronzing of legumes is due to chloride deficiency. The symptom appears as brown or bronze flecks on the upper surface of the leaves. These are seen in young leaves as well. And finally, we have mouse ear in pecan, which is due to nickel deficiency. The leaves start curling up like the ears of a mouse. There is also dwarfing of the leaves, meaning they start becoming small and the root shows poor development.